go quickly around the...
Thanks, Tom. I appreciate you guys coming here today. It's exciting to show and tell what we've done here in terms of the university, the campus. I'm extremely excited about what's occurred. I started about a year ago, a little over 12 months ago, and I was just telling Dwight and those folks earlier is that when you came onto campus at that time, there were no buildings, no roads, no lights, no anything. It was just a sand path. This building was starting to look like a building, and there was 3 Skanska trailers, and we had meetings out here at least once a week, if not, it went off and on to be daily meetings. But I would drive and get to the trailers, and we would just plan this campus, what's in this building, and all the buildings, and all the infrastructure, including the conduit, the internet services, all the technology that runs throughout this campus. And there's a lot of it you can't see. Later today we'll walk through, and I'll talk through some of the things that are really visible and we're really excited about. The mission of the university was to be the hub of the high-tech corridor between Orlando and Tampa, Central Florida, create a Silicon Valley-like feel, be that Polytechnic university that's unlike other universities. You could compare it to the California state system, which has Cal Poly and all those other California state universities that you know, Berkeley, Well, kind of like Florida. Florida needed a Polytechnic university, and that was the mission. The governor saw that, local politicians saw that, a lot of people saw that. So the economic model, I think people understand, and from the standpoint of us getting started, we wanted to be, well, our charter is to be STEM focused, science, technology, engineering, and math, and be market-driven degree programs, education, applied research, things that are transferable or translatable into the marketplace. So students that come through here, every degree and every concentration is, if you will, hot in the market. That's something that's market driven. So Jean-Paul, go ahead and advance. So let me, I've got just 3 slides, and we'll talk through these a little bit. So again, we're a brand new university with high-tech resources. And so what they said to me is, Tom, we need a leader of technology. We need somebody that understands this. And in the past, I actually worked for IBM for 13 years. Okay, and in that space, I actually started in the early 80s when John Akers was the CEO. I had a great opportunity. He was in Armonk, he was on the 3rd floor, I was on the 2nd floor. And at that point in time, we talked about being young. I wish I had the wherewithal to have better, to actually have a conversation with John Akers. I would just see him get in his limo to drive to the helicopter pad, and then from the helicopter pad he would leave and come back at some point in time. Really great leader. And so I just had some great experience with IBM. I was in the VM development lab, did some research and development, got into field tests and beta test programs. I ended up, we started the Worldwide Client Server Group. Next thing you know, I was consulting by the early 90s, and then I found myself at a lot of universities. And then in 94, I went to be the CIO at Virginia Commonwealth University in Richmond. And I've been mostly a CIO since 94. So in that regard, they said, well, we need modern classroom technology. We want to do high-speed networking, all advanced technology, everything brand new. So how do you design it? How do you architect that? How do you make that happen? Well, and around the December timeframe, I've been here a couple of months, and I was like, well, we've got pretty good academic programs, and we've got technology that is brand new, but still doesn't have the pop that I thought we needed to have. So I developed 6 innovation labs. And these innovation labs include the supercomputer lab, what we call the RAD makerspace, which is Rapid Application Development Makerspace, which I'll show you on the tour. Cybersecurity lab, media lab, entrepreneurship lab, and VTC robotics lab, which is visualization and technology collaboration robotics. with the leadership that's in this room, with Mark Wiley and his group, Ed Turetsky, Larry Landrut, Tom Mitchell, Eric Sutton, making this supercomputer happen was really a feat that I don't think has ever been seen in the state of Florida before. We started talking in the December, January timeframe. After a few conversations, we found it's now February, and to understand the state of Florida acquisition process, it's 18 months to do anything significant. I mean, 18 months. Well, by the end of February, we had communicated thoughts and requirements with Ed and Larry and Tom, Eric. We designed it, talking to Mark Wiley all the time and saying, can we really make this happen? And by March, we had a set plan. And by June, 3 months later, it was sitting in a room that was just going to be a classroom. But a classroom that we really didn't know what to do with. And I said, well, you'll see it. We had a glass wall, and I said, oh, this is going to be a showcase. First of all, we've got requirements with a student data center. So to run the programs that we need to run, the degree programs, we need a student data center. And we need high-performance computing. And we were able to solve that with one complex, a supercomputer complex. So, from high level down, we designed it. We had to put all kinds of environmentals into that room to make it happen. All that work was done in April, May, and June, in 3 months. Again, in the state of Florida, you've got ITN processes, and we went through them. We actually went through them. It was a competitive thing, and the leaders in this room won it. I mean, it was the best solution at the right time for the right requirements. And very exciting. High-performance computing, student data center. I happen to teach a database class, and I've got all the students using the virtual machine. Henry Chow is engineer, does a wonderful job in orchestrating the VMware environment that Ed had started with some other folks, like Bly, Flagship Solutions. Great group of resources. Again, real leaders that move fast. So, and I kid up at the University of Florida, they just started a high-performance computing. So now our academic, I've got just 2 slides on the academic programs, and I can go to the website too, which is a funky website. So at Florida Poly, in starting the university, so our first semester, our first day of class was August 25th. So just a couple months ago, brand new startup university on this campus. That again, if you were here 12 months ago, you'd say, you're going to need a couple years. You're going to need a couple years. 2 major schools, the School of Engineering, which includes a Master of Science program in engineering, and several bachelor degree programs, computer engineering, electrical engineering, and mechanical and industrial engineering. And I'll talk a little bit about the concentrations, and each one of these in the engineering space is in demand. Purposefully selected. The master programs, go ahead, jump ahead to the next slide. There's 2 master programs, so this is the other college, which is called the College of Innovation and Technology. You can get a Master of Science degree in Innovation and Technology. And the reason why they're called that is that within those master degree programs, we can actually combine different disciplines to be a master's degree. So it's not like we have to find 20 master's programs of, the old Master of Civil Engineering or electrical engineering. It can be electrical engineering with a combination of computer engineering. So it's actually unique per student. So, and that's true of both schools. And in the School of Innovation and Technology, in our bachelor degree programs, we have advanced technology, which are things that you'll recognize there, big data, cloud, health, computer science and information technology, and science and technology management. So each one of these are degree granting programs with concentrations underneath. So, you know, in developing these educational programs, like I was saying, you know, as we started in January, February timeframe, these programs hadn't really been defined. Some of them, we knew, at that point in time, we only had 3 faculty. Now we've got a full faculty force, and we're going to be doubling our faculty pretty much every year for the next couple of years. We're going to add several more faculty for the spring semester, same with the fall. We're going to include a lot more applied research and several more courses that are included in these degree programs. And we'll probably be adding concentrations as we go. So, Jean-Paul, so if you look at the College of Innovation and Technology, if you just hover, Jean-Paul, under each one of these, you can see these are our focused concentrations. Right? So where schools will say, oh, okay, I can get a bachelor's degree in computer science. Well, you can get a bachelor's degree in computer science here and focus on cyber gaming or cyber information assurance and cybersecurity. Same here with science and technology management, logistics, materials and supply chain. These are things that we see are very important out there in the industry. You know, it's not just you get a degree in MIS or something like that, right? We're purposely teaching these aspects. And the things that I see growing here are many more real-world, hands-on, software-based teaching programs. So in other words, for this, science and technology management, a lot of students will graduate from college in a computer science degree, never having been in a data center, never having touched a server, never having changed some of the things that a normal system administrator would do, and doesn't know what an ERP environment is. Can't spell ERP, doesn't know what it means. Well, in our case, we're teaching them. We're going to be adding that to our curriculum. So we can teach with several different packages that we can actually contain in a semester or 2 semesters of coursework that's part of our overall degree program. So that's the kind of thing that I think is very powerful. That's the kind of thing that we're very excited about. You could go down scroll down through the College of Engineering. A couple of our labs, and the person that just walked out is Dr. Ryan Integlia. He's been a great partner of mine, along with several of the other faculty. You know, don't be fooled. He did multiple degrees from Rutgers and Princeton, and I think the program that he was in he was one of 5 over the course of 10 years. We call him the beautiful mind. Saying all this while he's out of the room. So, you know, things that we're talking about giving students the experience of here include electron microscopes with our nanotechnology program. If you look at geometric dimensioning and tolerancing, 3D prototyping, rapid prototyping, Ryan, I was talking about you as you were out of the room, which I normally do. You just don't realize it.
All good, right?
You know, there's nothing bad to say, right? So it's, again, Ryan's background, his ability, I think, to see the things that are well beyond his years, the experience that he's had representing Princeton, bringing all that here has made this stuff happen, right? So you take these engineering programs and you translate them into things that we actually are doing in our labs, and that's what we've done. That's what we've done. I'll show you the grad makerspace and some of the things we're doing on the robotics. So that's the curriculum. You know, again, the good thing about starting a university is you can be creative. And when we talk about our master's programs and bachelor's programs, you know, we didn't just want to say, okay, this is a strict, rigid definition. As you can see, there is some structure to it, but underneath that structure we have concentrations. And those concentrations, again, are market-driven. There's flexibility to add concentrations without going through a whole statewide process or accreditation process that gets stuck in some red tape. We can add faculty, we can add to this program a lot more flexibly than other universities. So that's it. That's it. That's our mission, that's our vision. And again, I'll show you on the tour some of the things that we've accomplished in a short 12 months. And again, the supercomputer facility is one that, again, if we tried to do that, again, within a 6-month time frame, I think it'd be very difficult to finish. We just lined it up. We were all very motivated, and we had a sense of urgency. We made it happen. It had to be that way. We would not be able to teach the innovation technology program with degrees within that school. We would not be able to do so. And the excitement, you talk about tour stops. So earlier today, you might have missed it, but there were hundreds of students that walked through this building. And there was a major tour that we're giving. We actually give those every day. Some are 5, 10 students, some are 100. Saturdays are a big day for tours. And when those students see what we've done, it's like sold at that point. Radmaker Space and supercomputer. Those two things excite the number of pictures that have been taken with the mother and father and the student standing with the supercomputer in the background. Eric and Tom and Larry, as you guys can say, we had launch days in the summer, and Sean Malat, who's also here. Sean is our leader in industry partnerships, and we coordinated Launch and Pivot, which were two very major events this summer. The thousands of people that walked through that corridor, and we're so excited about the prospect of because of what we put in. It's very tremendous. It's exciting, and it's really wonderful to see that people get so excited about it. And we're just going to, we're just starting out. We're just starting out this semester. The progression, the development life cycle, where we think we're going to go from one semester to the next is leaps and bounds. We're very excited about the growth. Welcome, thanks for coming, and I appreciate your attention.